Hi, welcome to Futureproof Your Planet, our Sustainability Master Series, where we discuss how science, technology, fashion and engineering can help us make our planet more sustainable. Today we're doing material sciences and I'm joined by Tom.
Hi.
And you'll be watching a video about how we can go beyond the bans in terms of plastics, and afterwards Tom will be here for a Q&A for about 15 minutes where you guys can ask your questions.
Hi, I'm Tom McDonald. I'm a reader in sustainable materials at the University of Manchester. Welcome to my talk on tackling the sustainability issues in plastics. Every year the world produces around 400 million tonnes of plastic. This amount is staggering and equivalent to the entire weight of the human population. Even more alarmingly, it is estimated that the equivalent of 2,000 refuse trucks full of plastic are dumped into the world's oceans, rivers and lakes. This plastic pollution is not only a visual blight, but also a significant environmental and health crisis. However, despite this global problem, while it might seem like an obvious solution to ban plastics, given this environmental impact, the reality is banning plastics is much more complex. In my talk today, I'll talk about why banning plastics is not the solution. My talk will explore the complexities within the topic, covering the problem of plastic pollution, the importance of plastics in modern life, the innovations underway to improve plastic sustainability, and actions we can all take as individuals. Firstly, let's explore the problem. Let's look at the impact of plastics in the environment. Plastic pollution is pervasive, affecting every region of our planet. It's been found on top of our highest mountains and at the bottom of the world's deepest oceans. Our oceans, rivers, and lakes are inundated with plastic waste. This is harming wildlife and disrupting ecosystems. Marine animals often ingest and become entangled in plastic debris, leading to injuries and/or their death. Microplastics, which are tiny pieces of broken down plastics, have been found in various food items, from seafood to table salt. The impacts of these microplastics are not fully understood yet. However, they have the potential to carry harmful chemicals, which when ingested by humans, could accumulate in our bodies and pose health risks. Despite the severity of these issues, plastics play essential roles in our daily lives, making it crucial that we find balanced, sustainable approaches to managing plastic waste. Firstly, let's define plastics. Plastics are a type of polymer, and a polymer is a long-chain molecule. The characteristic property of plastics is that they can be molded, typically through heating, into shapes during processing. Non-plastic polymers include a whole range of materials also made of long-chain molecules. These include materials such as rubbers, resins, and even ingredients that are used in home and personal care products such as shampoo. As such, plastics and polymers play key roles in every aspect of our lives, from the packaging that preserves our food to the medical devices that save our lives. Plastics are indispensable. Imagine a day without plastics. Let's consider two different examples. Smartphones. In smartphones, the plastics are used to manufacture the electronics, the batteries, and polymer adhesives that hold the components together. In terms of healthcare, plastics are there to enable sterility, and they're used to make medical devices such as pacemakers and even bone screws. Our reliance on plastics is testament to their versatility and efficiency. Plastics, like other man-made materials, aren't an evil in themselves, rather the way we as society use, handle, value, and dispose of those materials that causes the negative impacts on the planet. We're now going to focus on the area of plastic packaging. This is because packaging is one of those topics we associate most strongly with plastic pollution. Firstly, we need to recognize why we use packaging. It provides a critical role in food preservation, hygiene, and transportation. It prevents contamination, extends shelf life, and reduces food waste. For example, vacuum-sealed plastic packaging can keep food fresh for weeks longer than traditional methods. This not only ensures food safety, but also significantly reduces the amount of food that gets thrown away. This is really important because food waste has been estimated to represent a staggering 6% of global climate emissions. This is more climate emissions than the entire aviation sector. As such, changes to packaging that increase food waste will be highly detrimental to global climate change targets. Why is plastic commonly used in packaging? Well, plastic is a lightweight and durable material that makes it ideal for transporting goods over long distances. For example, let's consider the mass of a product that is packaging. The lightweight properties of a plastic bottle, for example, combined with the mechanical resistance and toughness, means the bottle can be thin and provides a low mass. On the other hand, if we think about glass is a much more brittle and denser material. The bottle in this case will often weigh more than the product the bottle contains. Therefore, when we think about alternatives to plastic, it's important to consider the feasibility and sustainability of these options. Substituting plastics with materials like aluminium or glass isn't always practical or environmentally friendly. For instance, producing aluminium or glass requires significantly more energy than producing plastic. If we consider aluminium, the climate change emissions associated with aluminium are between 12 and 17 tons of CO2 equivalents per ton of aluminium. While for PET, the plastic used in clear drinks bottles, this value is much lower at about 2.4 tons of CO2 equivalents per ton of plastic. The environmental impact of different packaging options can be compared through a thorough process known as life cycle assessment, which considers all the climate emissions for a product from the extraction of the raw materials during its life and finally to the methods of disposal at the end of life. For packaging, it has been repeatedly shown plastics are the more sustainable material for the vast majority of options. They have the lowest climate change impact. So how do we maintain the benefits of plastics while addressing these sustainability and environmental issues caused by plastic waste? Plastic sustainability has three main approaches. The first one is replacing fossil fuel feedstocks. The second is using plastics in a more circular manner. And the third is using degradation when the plastics do leach into the environment. I'm going to discuss each of these briefly. In terms of replacing fossil fuel feedstocks, the focus is the development of bio-based plastics. Unlike traditional plastics derived from fossil fuels, bio-based plastics are made from renewable materials and resources such as cornstarch or sugarcane. This helps us by avoiding the extraction of more carbon that's currently locked away in fossil fuels and putting it into the atmosphere. However, when considering renewable feedstocks, these materials must not compete with the food production sector and rather should use residual foodstuffs such as agricultural waste as the starting materials. Researchers are continually improving the properties of these bio-based plastics to make them more versatile and applicable to various applications from packaging to agriculture. Researchers are also learning how to efficiently use bio-based waste as a feedstock. The goal here is to create materials that maintain the same benefits of traditional plastics while being derived from environmentally friendly sources. Let's talk about the use of plastics in a more circular way. This has a huge opportunity for reducing environmental impact and is enabled through significant breakthroughs in recycling technologies. At the University of Manchester, we're helping to drive some of these advances. Our research is focused on improving mechanical recycling processes to enhance the quality and usability of recycled plastics. By refining these processes, we're able to enhance recycled properties of plastics and make them as good as the virgin materials they replace. Degradability of plastic should be used as a last resort. This is because the CO2 contained in the plastic upon degradation will be ultimately released into the atmosphere. We should therefore only use degradation when it is not possible to recover the materials and use them in a circular, sustainable way. For example, a good application of degradable plastics are in highly contaminated food packaging, particularly in areas that have poor waste management. Researchers are focused on producing degradable plastics that provide excellent properties, for example, barrier properties, until the time they enter the environment at which they can degrade. Additionally, researchers at the University of Manchester are deepening the understanding of the impact of microplastics and nanoplastics on the environment and human health. By investigating sources, distribution, and effects of microplastics and nanoplastics, we aim to understand their effect on the environment and develop effective mitigation strategies. These innovations and research efforts are crucial steps to maintain a more circular, sustainable future. However, addressing the plastic problem isn't just about technologies we do in universities, it's also about changing our behaviour as individuals and communities. Let's briefly explore what you can do and we can do on a personal level to make a difference. You have likely heard the mantra, reduce, reuse, recycle. This isn't just a catchphrase, it is key to us all being responsible in our use of materials that are produced around us. As individuals, we can take practical steps to reduce our plastic consumption. We can reduce the use of plastic items with minimal pre-planning. For example, one simple but very effective action is to use a refillable water bottle instead of buying bottled water. Studies have shown that by reusing an aluminium bottle instead of buying a daily single plastic bottle, this results in a 90% reduction in climate change emissions. In terms of reuse, the reuse of plastic containers for storage and other purposes rather than discarding them is a great opportunity. These containers can then be used to contain household items, lunches, or storing leftovers. It extends the life of that material and also reduces the need to buy new items. Finally, when there's no options for reducing or reuse, then we need to learn how to recycle efficiently. Proper storing and cleaning of renewables can make a big difference in reducing contamination and improving the quality of recycled plastics. Currently, within the UK, different regions of the country have different recycling requirements. So ensure you follow your local recycling guidelines to maximise the efficiency of the recycling programs. There's a great website called recyclenow.com, which can be really useful for checking what can be recycled in your local area. We should also support and advocate for innovations in sustainable plastics and recycling technologies. This can be done by choosing products from companies that prioritise sustainable practices and use recycled materials. You can also look up targets set by companies and their progress against these targets on plastic packaging sustainability. Your purchasing decisions can drive market demand for greener products, pushing companies to innovate and adopt more sustainable practices. To wrap up, let's summarise the key points we've discussed today. While plastics pose significant environmental challenges, they are critical to modern life. From medical devices that save lives to packaging that preserves food, plastics are truly indispensable. Banning plastics outright isn't the solution. Instead, we need to focus on sustainable innovations that are responsible for driving sensible consumption. I urge you to rethink your relationship with plastics, recognise the value they provide within your life, and take actionable steps to reduce, reuse, and recycle all materials, not just plastics. Support companies that provide transparent information on their route to net zero and political activities that help create policies that enable more responsive consumption. Your choices, actions can drive significant change. Thank you for your attention and commitment to making a difference. Let's focus on a more sustainable approach to plastics to future-proof your planet.
Welcome back. We're going to start off with our first question for the Q&A. I've heard that plastics become less recyclable over time. Is this true? How do we make this less of a problem?
Yeah, I think this is a really interesting one actually, because you can think of plastics really, if we want to simplify it, like they're long chain molecules, aren't they? Mm-hmm. And essentially you imagine as you begin to put those under shear forces, so strong forces that are involved in the recycling process, they actually break down the chains. So one of the common things that happens in all recycled polymers is the chains get shorter, and that changes some of the properties of plastics. So this is predominantly really problematic in a plastic called polypropylene, which is what's used in, say, your yogurt pots and your butter tubs. And so what really needs to be done going forward is we need to think about how we can evaluate the amount of degradation that's happened in plastics. So this happens in a process called mechanical recycling, which is our main type of recycling, that the chains get shorter. So you might be able to evaluate it and say, well, rather than trying to use that plastic in packaging, let's use it maybe for an automotive application or maybe a lower performance application like garden furniture. So you could kind of rationalize where the plastic gets used for. And there's also another type of recycling people are trying to develop called chemical recycling, which is rather than using your long chains, you break it back down to the monomers, so the building blocks, and then you make your own polymers again. And so with that, you can essentially regenerate the polymer back to any required properties, really. So I think really we're going to see this problem of degradation becoming more problematic as there's more recycling. But I think as we understand that, we can begin to have that selection process of, applying the right plastic quality to the right application and then also trying to use chemical recycling when needed to build back the polymers up.
Great. The next question is, why haven't biodegradable plastics been more implemented yet if they're less harmful than regular plastic?
Yeah, again, a really nice point. I think if we think about biodegradable plastics and we think about the environment, one thing we're trying to do, well, I'd say there's two things we're trying to do, aren't we? We're trying to reduce our climate emissions. So from a biodegradable perspective, actually, that's suboptimal in many ways. If we've used the energy to make plastic and then we leave it out and it degrades and produces carbon dioxide, we've essentially just put that carbon into the air. So where we deploy biodegradable plastics, we've got to be really rational in how we're using those. So you wouldn't want to use it in, say, bottles, really, where we can recover it really effectively. But biodegradable plastics are generally going to be much more effective from a packaging perspective in, say, food contact, where you're going to, you get your film on the top of your meal, and that's going to be coated in food. It's very hard to recycle. And so then if it was degradable, if it leaches into the environment, it's going to degrade rather than forming, plastic pollution. But I think it also really depends where these plastics are deployed in the world. So in places where we've got really good waste management infrastructure, there's less plastics leaching into the environment, and therefore having them being degradable is less important. But I think in places in the world where we have much less developed waste management infrastructure, there's a lot of plastic pollution that leaches out, and therefore it would be a benefit to deploy it there where we could actually have less plastic pollution, building up in lakes and rivers.
You mentioned earlier about how the wrappings of food, how they're harder to recycle. So as a whole, how efficient is plastic recycling or materials recycling?
Yeah. So it really depends on the plastic type. So the plastics we have, the main three plastics we have are PET, polyethylene terephthalate, which is your kind of clear, transparent drinks bottles. So that's really effectively recycled. So in the UK, we can get up to maybe, you can get 100% recycled content, and a lot of our bottles will be 80% recycled content. So that's a really well-established market. And then there's polyethylene, which is mainly used in some of our other bottles. That market in the UK is also quite well developed. And then polypropylene, as well, as I mentioned before, is used in some tubs. That's also growing. Where we're wrapping things, those plastics are much more complex because you've got a really thin piece of plastic and you need it to have barriers against moisture and oxygen to, say, protect the food. And those are normally made of multiple plastics layered up. And so those are really challenging to recycle. So really, from a plastic film perspective or thin films, I think that is something where there is a lot of investment in research trying to look at how you can maybe selectively remove one type of plastic to get the others back, and then you could, once you separate them, you can try and recycle them separately. But the big challenge there is contamination. There's a lot of contamination on anything that wraps your food.
Yeah. Do you believe that in the future it will be possible to create degradable plastics which can also recycle?
Yeah. So I mean, there's the question here about what is degradable, because obviously everything kind of degrades over different timescales. So there's a degradable plastic called polylactic acid, PLA, and this is often used in 3D printing applications, but also it's used sometimes in cups that might replace your polystyrene cup you get from a drinks machine that just fills your cup up. That those can now be made out of PLA. Now PLA is degradable, but only degradable in industrial. It's not furnaces, but in industrial kind of incubators. And so depending on where you are in the world, they're never really degraded in the proper situation. So really, I think there are people now researching more and more to try and design plastics that could be, say, mechanically recycled, so heated up, melted, reformed lots of times, but then have bonds, so regions of the molecule you can break chemically under certain conditions, so that then you can regenerate your monomers, your building blocks, to make your polymers back up. So it is an active area, and there are some kind of degradable plastics on the market. But in many ways, we don't want our plastics to degrade much, because as we talked about it in the first question, every time we recycle it, they're degrading. Yeah. So there's this interesting balance between degradation and kind of preventing degradation.
Yeah. As much as we can't ban plastics, can't we ban its production, and companies and businesses can reuse and recycle what already exists?
Yeah, I think in terms of that there was the plastic treaty that was sadly failed in the UN as part of the kind of COP negotiations, and that was really trying to reduce how much new virgin plastics we're producing. And I think, yeah, there's definitely an element of, generally we need to consume less of everything. If we have less, if we have less new things, we don't need to have as many materials being extracted of whatever material, including plastics. I don't think our recovery is high enough of plastics to be able to, sustain a kind of closed loop. But I think I think fundamentally we're always going to need some new plastics to feed in. But I think long term there's a really strong interest in moving away from fossil fuel derived starting materials to using materials from say agricultural waste. So you can make polypropylene, for example, from agricultural waste, which I think is going to be a really exciting opportunity.
On the vein of that, what types of bioplastics are being developed in Manchester?
Okay, yeah. So I think in terms of, for us, I can't speak across all the different research activities in the university. I think there's an interesting element of like a novel plastic, like completely new monomers. There'll be loads of different people looking at that in Manchester. I can't tell you the specifics about what types of plastics they're trying to make. But I give an example. So if you think about it for, say, composites, so, like a composite that might be used in like an aerospace or automotive application where you have a polymer matrix and you have fibers in it. So the fibers help give you a lot of the properties. So some of the researchers here are trying to design the resin, so the polymer that goes around the fibers, to be selectively degraded. So you could have your aerospace composite, your composite in use, and it's really robust, non-degradable. Then you'd expose it to its trigger, and then you'd degrade it back down to its monomers. So there's some of the research groups actually in materials are looking at that as a specific area.
The last question from the chat would be, would it be better to use plastics or as alternative like glass or aluminium when making tools or equipment in the medical field? Also, if biodegradable plastics is used in the medical field, would it be safe?
Oh, yeah. So this is actually something that aligns with one of the research projects we're doing at the minute. So we've got a project working with Bupa, so they're like a UK private medical provider, and we're actively working with them to look at where we can either reuse more plastics or recycle more plastics used in both dental and health applications. And really, we're trying to look at this from a few aspects. One is the social science bit, to understand, why are people using plastics? Why are they using single-use items? Because I think whenever we're trying to replace, we want to replace any item, we need to understand why it's been used. Why does that person choose that item? So we're looking at the social science bit. Then we're studying the material properties. And then we're also using a tool known as life cycle analysis, which lets us understand whether a new approach has a better environmental footprint than the old approach. And to come back to your question, it really depends on the circumstances. So a lot of times plastics have been brought into healthcare because they're maybe more convenient, but also maybe they're safer and more sterile. So it's really trying to look at, can you say use metal items, and does the sterilization use more energy than using a single-use item? In terms of degradable plastics in healthcare, I think a really key thing we've got to think about any material we use is actually what happens at the end of its life. Because at the end of its life, if it's incinerated, it doesn't really matter if it's degradable or not, because it's going to be burnt. As I said, degradation really matters if it's going to leach into the environment, I think.
Yeah, perfect. And for our final question,
Okay.
do you have any advice for any students who would want to join the university in material science?
Yeah. I think for me, the thing that I'm really passionate about from a materials perspective is just the diversity. I think in materials, obviously I'm talking a lot about plastics today, but like we've got plastics, ceramics, metals, composites, a whole diverse range of different materials that really just underpin our modern life. And I think particularly on the sustainability topic, materials innovation is going to be key to driving things forward. We need to look at how we can make transport more efficient by lightweighting. How can we capture more energy efficiently from solar and so on. Battery technologies as well. So I think material science is just a really exciting area. And when you start as an undergraduate in materials, you can actually really explore those, which topic is most interesting to you, and later on in your degree you have a chance to kind of think, oh, I'm more interested in polymers maybe. But you can choose whichever topic you like, and it's a really underpinning, I think, area of science.
Thank you so much, Tom.
Cool.
If you guys have any more questions, you can leave them in the comment section for the next 10 minutes, then someone will come to your answer. You can join us next Monday where we'll have another talk then, and that's all.
Cool.
Thank you again.
Thanks.